This video lecture is going to cover solving linear equations in one variable. The first thing that you need to take a look at when we're considering solving linear equations is the addition and subtraction property of equality and the multiplication and division property of equality. Both of these are in your textbook in this first section. On, I think, the very first page, in fact, of the first section. What they say essentially is that if you do something on one side of the equation to be able to isolate the variable, then you have to do the exact same thing on the other side. For example, if we needed to add 3 to one side, we would need to add 3 to the other side also to keep the equation in balance. A linear equation in the single variable x is an equation in this form. A times x plus b is equal to 0. Now what that means is that the equation itself can be put in that form. It may not look like that to begin with, okay? And the a and the b, okay, have to be real numbers, and a cannot be equal to 0. Okay, let's work a little example problem. I'm going to scoot the screen up just a little bit here so we can see what we're doing. Okay, here's our example. Now for most of y'all, this is going to be just a review, so you're going to pick right up along with this as we go. And if you're having any trouble with it, you can ask me about it in class. 9 minus 3 times 2x plus 4 is equal to 5 times 1 minus x minus 4, okay? Now, included in this example is a property that we haven't talked about yet called the distributive property. Now, you should already be familiar with this, but basically what it tells us is if we've got something like this expression right here, as part of our equation or expression, either one, what we're going to do is take the number that's out in front that's being multiplied times the parentheses, and we distribute that number to each term inside the parentheses. So what we're going to be doing is multiplying that negative 3 times the 2x and getting a value, and then the negative 3 times the 4 and getting a value. We'll do the same thing over here with the 5 times 1 minus x, okay? So let's get started. You start with that distributive property first to kind of clean things up a bit. With equations, you want to simplify first and then start moving your terms around so that you can isolate your x, all right? So if we multiply the negative 3, and don't forget about that negative, okay? A lot of mistakes are made here by not distributing the negative 3, just distributing a 3, okay? So negative 3 times 2x is 6x, and then negative 3 times times positive 4, sorry, is going to give you a negative 12, okay? Now, like I said, there's a lot of mistakes made with the negative there in front of the number that you're distributing, and I tend to make these a lot myself. So just be sure that if there is a negative on the number you're supposed to multiply through the parenthesis, you take it with you, okay? You can go ahead and clean that up now if you want to, combining your like terms, or we can go ahead and go to the other side. I'm going to kind of keep it balanced, so I'm going to work on both sides at the same time. Distribute the 5 times 1. Minus 5 times x minus 4. All right, now combine, and we're going to have 9 minus 12 is going to give me a negative 3, okay? So combining those two constants, we get a negative 3. The negative 6x just hangs around for a little while longer. Then combine the 5 and the negative 4 to get a positive 1. All right, now we've got a variable term and a constant on each side, so we have to move the terms to get the x's together. You have several different choices as to how to start this. What I will typically do is start by moving my x's to the left, unless there's some good reason why I shouldn't, okay? That's not the only way to work it, that's just the way that I usually do it. So what we would do here, and I'm going to do something here that I'm not normally going to do when I show you guys examples in class or on videos, either one, but it's something that you may need to do at least at first to kind of keep straight what you're doing, okay? So I want you to see it done like that. Whoops, sorry. I was trying to push the page up, and I hit the wrong thing. Hang on one second. Well, Never mind. Okay, maybe I've got an eraser somewhere. Okay, anyway. Let me move it up. So I'm sorry, I'm not used to this video software. Okay, let's try this. Okay, now what we're going to do is add the 5x to both sides to get rid of it over there on the right-hand side. So we add 5x. Okay, and that's going to give me a negative x here. We still have the negative 3 equals 1, but we lose all of the 5x. So all the x has been moved to one side, okay? Now you do the same thing with a constant. You push it over to the other side. So for this, we would add 3 to both sides. Like I said, I won't always do it this way, but you can if you want to, if it helps you out. That's going to leave you with a negative x on the left because the 3's are going to add out to 0. Is equal to a positive 4. Now here what we need to do is completely isolate x by dividing both sides by whatever the coefficient on x is. In this case it's just a negative 1. So we'll do that, and again that's a step you don't have to show, okay, literally writing the negative 1 under each one, but you may need to kind of keep things straight for yourself. Alright, that's going to give me x is equal to negative 4. Now once you get an answer, you can check that if you want to by plugging it in to the original equation. That's not a necessity. Some people wind up checking an answer and check it wrong and think the answer's wrong and then try to fix the answer when it's actually a correct answer. So just be real careful if you do decide to check, okay? Check, whoops. There's the eraser. Sorry, I couldn't find it earlier. Now I've got it. Check, well, by plugging in the solution where x is in the original equation. Okay, so that's the only example I'm going to give you on a video for this one, since this topic is pretty easy and should be kind of a review for you, okay? So we'll do a few more of these in class, and then you can move on to the next topic.